Good evening. I'm Joshua D. Mindaros, PACA 3B, and I'm going to discuss all about the total hydrostatic force on plane surface. Before we proceed to our main topic, which is the total hydrostatic force on plane surface, I will discuss first the principles of hydrostatic since we can apply this in our next topic. So pressure. It is the ratio of normal force to area at a point. It is the force per unit exerted by a liquid or gas on a body or surface with a force acting at right angles to the surface uniformly in all directions. In finding the pressure, pressure is equals to magnitude of normal force over the unit area. Hydrostatic pressure. Hydrostatic pressure is the pressure that is exerted by a fluid at equilibrium at a given point within the fluid due to the force of gravity. It acts equally in all directions. It acts at right angle to any surface in contact with the fluid. So we have a cubical tank. If this is the water surface at the top, this is the black arrows niyan, centered at the top, centered that the pressure increases proportion to depth. It means the deeper it goes, the higher the pressure at each point within the tank. So the face of cubical tank that are in contact with the fluid are these faces. So karang naka-blue nga murag V, including the bottom that part of this cube, so centered that the pressure act equally in all directions. That with respect to the depth of fluid, so we consider this level, it means this elevation of the pressure are equal. Pascal's law, developed by French mathematician Blaise Pascal, states that the force applied to a confined fluid is transmitted uniformly in all directions throughout the fluid regardless of the shape of container. So absolute pressure, gauge pressure, and vacuum pressure. When we say absolute pressure, it is a pressure that is relative to the zero pressure in the empty air free space of the universe. This reference pressure is the ideal of absolute vacuum. Second is the gauge pressure or the relative pressures. Are pressures above or below the atmosphere and can be measured by pressure gauge or manometers. The difference between an absolute pressure or P-abs and the prevailing atmospheric pressure or PATM. Vacuum pressure is a measure of the pressure of a gas in a space where the pressure is lower than atmospheric pressure. The atmospheric pressure is the pressure at any point on the Earth's surface from the weight of the air above it. So barometer is used to measure atmospheric pressure. It's also called barometric pressure. So the formulas in finding the gauge pressure or P gauge is equals to absolute pressure minus atmospheric pressure. In finding the vacuum pressure is atmospheric pressure minus the absolute pressure. Or in finding vacuum pressure is equals to negative gauge pressure. So variations in pressure. Next is the variation in pressure. So we have the liquid surface and this picture. So this the point 1 is the pressure 1 and the point 2 is the pressure 2 and h is the height. To determine the change in measure change in pressure between 2 points in a fluid, so we have change in pressure is equals to unit weight times the height, or pressure 2 minus pressure 1 is equals to unit weight times height. So let's say we have a given pressure at point 1, so natay pressure dire sa point 1. So determine the pressure at point 2. So to find the pressure 2, so pressure 2 is equals to unit weight times height plus the pressure 1. So assuming that point 1 on a free liquid surface, then the gauge pressure is 0. So kung ang so if the pressure 1 is equals to 0, so atong formula nga gamiton is pressure is equals to unit weight times height. If mag-assume ta that the point 1 and point 2 lie on the same elevation, so kung ang point 1, point 2 are the same elevation, so it is considered that the height is equals to 0. So point 2 is equals to point 1. So next is the pressure below layers of different liquids. So we have a closed tank with 3 layers, and we have a pressure at the top, which is the air pressure. We have the liquid A, liquid B, and liquid C. So to determine the P bottom is equals to the summation of unit weight times height plus the air pressure, or P bottom is equals to unit weight sub 1 times height sub 1 plus unit weight sub 2 plus times height sub 2 plus unit weight sub 3 times height sub 3 plus air pressure. So we are now in our on our topic, the total hydrostatic force on plane surface. Total hydrostatic force on plane surface, and the pressure over a plane area is uniform, as in the case of a horizontal surface of the bottom of the tank filled with liquid. The total hydrostatic force or the total pressure is given by force is equals to pressure times the area. So where P is equals to the uniform pressure, and the E is the area of horizontal surface subjected with the pressure. So take note that we can only use this equation if the given plate of surface is submerged on the horizontal surface, like in this figure. So what if we encountered mga inclined or vertical planes submerged in a liquid? So the formula that we use is force is equals to unit weight times bar H times area, or PCG is equals to unit weight times bar H, or force is equals to PCG times area. So where F is equals to the total hydrostatic force acting normal to the plane. A is the area of plane in meter squared. The bar H is equals to vertical distance of CG from the liquid surface, and the CG is the centroid of the plane. So to find the eccentricity, so eccentricity is equals to IG or over A bar Y. E is equals to eccentricity CG to CG. IG is the centroidal moment of inertia. And A is the area of plane surface, and bar Y is the distance of CP from free surface along the axis of the plane surface. First example of a total hydrostatic force. So a rectangular gate is submerged with its top edge 3 meters below the water surface. A rectangular gate 2 meters wide and 4.5 meters high. So find the total pressure acting on one side of the gate and its location from the bottom. So ang required ani niya is the total pressure and the location from the bottom. So first we must illustrate siya. So kung this is the rectangular gate, so 2 meters wide, 2 meters, and the height is 4.5 meters, 4.5, and it is submerged with top edge 3 meters below the water surface. So if this is the water surface, and this 3 meters. So this is the CP, or the center of pressure, and the sorry, this is the CG and this is the CP, or center of gravity and center of pressure. So from CG to CP, so we have the eccentricity or the A. So from the eccentricity to the water surface, it is the bar H. And from the eccentricity to the bottom, so we denoted as the variable y. So the formula that we use is force is equals to the unit weight times bar H times the area. So first, so we must find bar H. So in this illustration, so to the bar H is from E to the water surface. So this is H over 2 and H over 2. So what is the half of 4.5? So, 4.5 divided 2. So it is 2.25. So 2.25 plus 3 meters. So our bar H is 5.25. So proceed. Since nakuha na nato ang bar H, so makuha na nato ang force. So force is equals to unit weight of water, which is 9.81, times the bar H, which is 5.25, and the area of finding the rectangle, which is length times width, so 2 times 4.5. So 9.81 times 5.25 times 2 times 4.5. So 463.52. And the unit is in kilo Newton. So, and second na atong pangitawon is the location of the bottom. So, sa iba doon. Space. So, first is you must find the eccentricity. So, in finding the eccentricity, so formula is Ig over area times bar Y. So, the formula in finding the moment of inertia is BD cube over 12 bar Y. So, 2 times 4.5 cube 12 is 2 times 4.5, then bar H is equals to bar Y. So, ang bar H na to is 5.25. So, our A is 0.32. So, makuha na to sa Y. So, Y is equals to bar H minus A. So, bar H is 5.25 minus 0.32. So, our Y is 4.92. So, muna na itong continuation sa itong example. So, for example, for number 2, determine the magnitude and location of the total hydrostatic force acting on the 1.5 meter and 3.5 meter gauge shown in the figure. So, in this problem, we have a figure, and the air pressure is 40 kPa, the specific gravity of the oil, which is 0.80, and the water and the glycerin, which is the specific gravity is 1.26. So we have also given the height of this. So since naman siya yung mga in finding the total hydrostatic force, since na siya yung specific gravity nga mga given, so atong formula nga gamiton is force is equals to PCG times the area. Yan. So di man ta makakuha din sa force since ato pa i-find ang PCG. So PCG is equals to summation of unit weight times height plus yung air pressure, which is the P. So 9.81 times specific gravity sa oil, which is 0.80 times the height, which is 1.5 plus 9.81 times 2 plus 9.81 times 1.26 times 4.5 plus yung pressure niya, which is 40. So our PCG is equals to 9.81 0.80 times 1.5 plus 9.81 is 2 times so 127.01 kilo kPa. So since nakuha na nato ang PCG, so makuha na nato ang total hydrostatic force. So force is equals to PCG, which is 127.01 times the area of this rectangle, which is 1.5 times the times 3. So 127.01 times 1.5 times 3. So 571.545 kilo Newton. So mga na itong answer sa hydrostatic force. So ang ato na pong sunod ko haon, which is the location of the total hydrostatic force. So ang ato na pong kaon sunod is the location. So sa ning baton. So ato ang force is 5.545 km. So solving for E. So solving for E na ta. So before na to makuha ng eccentricity, so ato sa pangitaon ng bar Y o bar H. So force is equals to unit weight times bar H times area. Since na naman tayo force, so pwede ito mo gamit aning formula. So 571.545 is equals to unit weight is 9.81 times ang specific gravity sa glycerin, which is 1.26 times bar H times the area, which is 1.5 times 3. So makuha na nato ang bar H. So 5.71.545 9.81 times 1.26 . So 10.28. So bar y na po. Bar y is equals to, since naman tayo given nga theta, so bar h over sine 60 degree. So atong bar h is 10.28 over sine 60 degree. So bar y is equals to 11.87. So pwede ta mo proceed na sa kuha sa E. Ito na nipat na yun. Atong bar y is 11.57. So eccentricity is equals to Ig over A bar y. So BD cube over 12 over area bar y. So 1.5 times 3 cube over 12 over the area, which is 1.5 times 3 yung sa bar y is 11.87. So kuha na nato ang E. So 1.5 so 0.06 ang atong E. So to find y, so y is equals to katunga aning 3, which is 1.5 minus 0.06. So our y, or the location, is 0.9.